The Romans didn't just fight wars, they engineered them. Every weapon, formation, and siege machine they built had a purpose, and that purpose was efficiency. They studied every detail of battle like a science, turning chaos into a system that could be repeated anywhere in the world. From the flexible Gladius to the massive siege towers, Roman warfare was less about luck and more about design. These were tools made by problem solvers who treated the battlefield like a workshop. What's fascinating is how their inventions didn't just win wars back then. They shaped how armies fight even today. So, let's take a closer look at 8 Roman weapons so clever they changed warfare forever. Number 1. The Pilum. The Pilum was the Roman opening move, and a quiet piece of engineering that did a lot of work before swords ever touched. Picture a javelin a little over 2 meters long, with a wooden shaft and a long narrow iron shank that ended in a hard pyramidal tip. That tip punched through shields with a small, brutal hole, and the thin shank slid in after it. The result was more than a puncture. It stole control of the shield. The enemy now held a heavy board with a spear stuck through it and a lot less room to maneuver. Roman soldiers typically carried 2 pila and let them fly just before closing. The goal was simple: break the line, mess up the shield wall, and walk into close combat against men who were suddenly exposed. Museums hold plenty of real Pilum heads that match this picture. They show the classic longshank and compact point, and they come from forts across the old provinces, which tells you how standard the kit became. The design details varied in smart ways. Some heads were attached by a flat tang riveted through the wood. Others used a socket. Both methods held firm at the moment of impact. There were heavier and lighter versions, which let commanders balance throwing distance against punch. Reconstructions and tests suggest you could lob one effectively from a short run at ranges that kept accuracy and killing power intact, and the Roman habit was to do this at close distance right before the crash. A lot of people have heard that the Pilum was built to bend on impact. The truth is more nuanced. Some examples bent when they hit hard surfaces, and that bend certainly made a captured javelin hard to reuse. But modern scholarship and experimental work point out that bending was often a byproduct of the long, thin shank slamming into something, not the only point of the design. A different trick sometimes credited to the General Marius is the famous wooden peg meant to snap and make removal difficult. Ancient writers mention a change, and later authors repeated the story, but archaeologists do not find a consistent switch across the army. It looks less like a universal reform, and more like one variant among many. What was never in doubt was the Pilum's job in a Roman attack. It forced an enemy to choose between dropping the shield or fighting with a shield fouled by a long iron bar. Either choice opened gaps. That is exactly when the short sword and big shield of a legionary ate ground. Ancient texts also show another side of the Pilum. If the throw did not happen, or after the throw, soldiers could use it like a spear in a pinch. Commanders told frontline ranks to hold their pila forward against charging cavalry and to jab up at riders and horses. That speaks to a weapon with enough stiffness in many versions to thrust as well as throw. Art and reliefs from imperial monuments back that up, showing pila carried on the march and stacked with other gear, which hints at how common they were and how they sat in everyday drill. Even small details helped. The pyramidal point was tough and concentrated force. That shape acts like a can opener against layered materials, which is exactly what a shield and a tunic and a cuirass create when stacked together. The longshank gave reach through that sandwich and made yanking the thing out slow and awkward. It also put weight far from the hand, which added to the lever effect when the enemy tried to wrestle the shield free. Put this together, and you can see the quiet genius. The Pilum was not a flashy hero weapon. It was a system tool. It set conditions for the next 30 seconds of the fight. It took a formed line and turned it into a mess at the exact moment Rome wanted to move in shoulder to shoulder. That is why it lasted for centuries and spread anywhere legions built camps and marched roads. It solved the boring, brutal problem of getting through a shield and into a man, and it did it in a way that fit Roman discipline and timing. Number 2. The Gladius. The Roman Gladius looked modest at first glance, yet it reshaped how infantry fought and won. Picture a short, double-edged blade designed to work in the tight space behind a shield. Most examples were around half a meter long, which meant a soldier could thrust without opening his guard. That length also kept the blade light and quick. You did not need a big swing to do damage. You needed a steady stance, a firm grip, and a clear target. Roman drill built exactly those habits and turned a simple sword into a reliable tool for breaking enemy lines. The shape of the gladius changed over the centuries in small but telling ways. Early on, during the Republic, soldiers carried what many call the Hispaniensis type, likely inspired by Iberian designs. It tended to be a little longer and had a strong point for deep penetration. Later came the Mainz and Fulham styles, with pronounced waists and leaf-like profiles that made wounds hard to treat. By the 1st century, the Pompey type became common with straighter edges and a shorter point. That made production easier and handling faster. None of these shifts were cosmetic. They reflect an army that watched results, learned, and adjusted. The gladius lived in a system with the Scutum shield and the Pilum javelin. The javelin wrecked shields and momentum. The shield protected the body and set the rhythm of advance. The sword finished the job. Roman soldiers fought shoulder to shoulder, pushed forward behind curved shields, and stabbed into the nearest openings. They aimed under ribs, into the belly, the groin, or the throat when the chance appeared. A thrust took less space, exposed the arm for less time, and was easier to repeat without losing formation. In a grind of men and wood and iron, those small advantages grew into a decisive edge. Training made the difference. Recruits learned to strike at marked targets and to keep their feet quiet and stable. They practiced with wooden swords heavier than the real thing, so the actual gladius felt lively on campaign. Instructors punished showy cuts that opened the body. They rewarded quick stabs that could be chained behind a shield punch. Over time, this turned the legionary into a calm machine. He did not chase duels. He stuck to his lane and backed up his neighbor. The sword amplified that mindset because it worked best when the soldier trusted the formation. Materials and construction also matter. Blades were pattern welded or piled from different irons, then hardened and tempered to balance strength with resilience. Many had a shallow fuller that reduced weight without making the sword flimsy. The hilt was simple and ergonomic, with a spherical pommel that locked the hand in place. The guard was not large, which matched the idea that the shield did most of the protecting. Scabbards hung on the right side for most legionaries, which kept the draw clear when the big shield sat on the left arm. Officers and some specialists wore theirs differently, but the standard setup kept movements predictable across the line. On the field, the gladius proved its value against many opponents. It could slip around long spears once a formation closed. It could punish loose shield work among tribal warriors who favored big overhead cuts. It could keep working even when fatigue set in, because the stroke was compact and repeatable. When Romans fought in sieges or streets, the short blade fit narrow spaces like stairs, alleys, and breaches. When fights dragged on, a dependable stabbing weapon helped men hold discipline instead of spending energy on wide swings that did little but tire the arm. Over time, the army shifted toward the longer spatha as tactics and cavalry roles evolved. Yet that does not diminish what the gladius achieved. It matched the legion at its peak, when heavy infantry decided most battles, and when order and patience beat drama. The sword embodied that philosophy. It favored method over flair, teamwork over heroics, and control over chaos. That is why it changed warfare. It proved that a short blade in trained hands, backed by a shield wall and steady drill, could outperform larger weapons built for spectacle. The gladius turned the Roman front rank into a cutting edge that did its work one steady thrust at a time. Number 3. The Scutum. The Roman Scutum was more than a big shield. It was the moving front door of the legion, and the reason Roman infantry could walk into danger with a straight face. Ancient writers described a tall, convex board, wide enough to cover most of the body, and archaeology backs that up with a rare surviving example from Dura Europos. That find shows a curved rectangle built from thin wooden strips laminated into a kind of ancient plywood, then covered in canvas and hide for toughness. A domed metal boss sat over a handhole at the center, so a soldier could grip a stout bar and punch forward without smashing his knuckles. Dimensions from texts and the Dura piece land in the same ballpark, roughly a man's chest to knee in height, which explains why it worked like a portable wall. Weight estimates suggest a load that a trained soldier could carry all day, heavy enough to feel safe, but not so heavy that it killed stamina. The Scutum evolved as Roman warfare changed. Early shields were often oval and sometimes flatter. Then the familiar arched rectangle became common as the empire grew. Reliefs like Trajan's column show how it sat in the line, edge to edge with the next shield, turning many men into one surface. That shape mattered. The curvature wrapped the body, pushed incoming blows aside, and gave structure to the famous Testudo, when shields locked in front and overhead to make a slow but stubborn box against arrows and stones. In open battle, the Scutum set the rhythm. A legionary stepped, shoved with the rim or boss, and stabbed around the edge with a short sword. The shield did not just absorb hits, it made space for the blade and hid the motion of the hand. In a crush of bodies, a small, clean thrust is easier to repeat than a big swing, and the Scutum made those thrusts possible. Construction details tell the same story of smart trade-offs. Laminated wood saved weight and resisted splitting. Canvas and rawhide skins helped against cuts and weather. Metal edging appears in some finds and depictions, but many shields relied on bound hide, which was lighter and easier to repair in the field. Paint was not only for pride. A red ground with symbols like wings and thunderbolts made units recognizable in smoke and dust, and the pigment helped seal the surface. The vertical hand grip behind the boss let the soldier punch and brace, while the long spine of the board spread shock down the arm into the body. On the march, the Scutum slung from the shoulder, but in a fight it lived in the left fist, which is why legionaries usually wore the sword on the right to avoid clashing gear. In sieges and street fights, the shield became a tool as much as armor. It bridged ditches, climbed rubble, and pushed enemies off balance at doorways and ladders. None of this worked without training, so recruits drilled how to keep the front flat, how to overlap edges, and how to close gaps on command. When the Scutum did its job, the enemy did not face individuals. He faced a surface that moved, pressed, and did not panic. That is why this shield changed warfare. It turned protection into a plan and made formation fighting the Roman superpower.
Number 4. The Ballista. Think of the Ballista as Rome's long arm that reached out before infantry ever touched shields. It was a torsion engine powered by bundles of twisted sinew or hair that stored energy like a living spring. 2 short arms sat in frames on either side of a stock. A thick string linked the arms, and a winch hauled that string back until a trigger released a violent snap. The result was a heavy bolt or a stone leaving the bed with shocking speed. Roman authors treated these machines as part of standard kit, and engineers treated them like instruments that needed tuning. Dimensions were scaled from the length and weight of the projectile so crews could replace parts and keep performance predictable. Over time, the army fielded 2 main families: bolt shooters that punched narrow missiles through ranks and shields, stone throwers that lobbed spherical shot to smash walls, towers, and dense groups. The same torsion principle drove both, yet their jobs were different. In the field, bolt shooters sat on hills or near the line to pick off chiefs and standard bearers, and to rip gaps before the clash. In sieges, stone throwers battered positions and kept defenders from showing their heads. Ancient accounts and modern archaeology line up on the effect. At Jerusalem, watchers on the walls learned to call out the approach of pale stone shots so men could duck, which tells you 2 things at once. The flight was visible at distance, and the impact was lethal. Modern studies and field trials estimate practical shooting at a few hundred meters for both families, with direct fire for bolts and high arcs for stones. Finds across the empire back up the paper trail. Museums hold iron bolt heads from Roman forts in Britain with long, narrow shanks made to pierce deep. Excavations in Judea and Syria bring up heavy stone balls near walls and gates where machines once stood. In a few places, the ground even preserves inscriptions and fittings that point to artillery stations and regular crews. The technology did not stand still either. By the early empire, smiths introduced metal frames in a compact design often called the Ballista. The change stiffened the structure, improved energy transfer, and made calibration more consistent from crew to crew. Late imperial writers mention cart-mounted versions that could follow a legion on campaign. That mobile gun line turned ambushes and river crossings into safer tasks because the army could answer missiles with missiles before the lines met. Range numbers vary with size and build, which is normal for handmade engines. What matters is the pattern. Bolt shooters could do precise work inside a few hundred meters and punch through shields at killing distances. Stone throwers reached farther and controlled space with area damage. Crews could manage 3 or 4 shots a minute when things were smooth, and slower when aiming for single targets. The cost was weight, rope wear, and the constant need to keep skeins dry and tuned, which is exactly why Rome invested in specialists and manuals. The real power of the ballista was not only physics, it was the way it changed behavior. Defenders stayed off the battlements. Cavalry gave artillery zones a wider berth. Enemy commanders learned to move under cover and to mask banners that drew fire. Meanwhile, Roman infantry advanced behind a storm of engineered fear that made every step safer. Put simply, the ballista taught ancient armies that the battle started long before bodies collided, and that engineering could shape the mood and the math of a fight. Number 5. The Onager. The Onager was Rome's stone-throwing workhorse, and it ran on twisted rope and careful math, not magic. Picture a stout wooden frame with a single vertical arm sitting in the middle. That arm was locked into 2 tight bundles of sinew or hair that acted like springs. Crews cranked the arm down with a winch and held it on a trigger. When they released it, the arm snapped up and hurled a stone from a cup or a sling. The shot climbed in a high arc and came down with a blunt kind of authority that walls and packed ranks could not ignore. Roman writers said the name came from the wild ass because the machine kicked hard when it fired and even shoved its own frame backward on the ground. That kick tells you how much energy the skein stored and how much care crews needed to aim, brace, and keep the mechanism healthy. The first clear mention of an onager by name shows up late in the empire with Ammianus Marcellinus, who wrote in the 4th century and treated it as a single-armed torsion engine, rather than the twin-armed ballista. Modern historians point out that stone throwers existed much earlier, while the exact labels in texts shifted over time, which explains why sources use ballista for some stone machines and save onager for the later single-arm style. The practical job stayed the same. Crews used onagers to smash battlements, sweep defenders off parapets, and break up close formations outside the walls. Finds of carved shot at sites like Masada and across the Near East show where machines once stood and how they worked a target over time. Experiments with reconstruction suggest useful ranges of a few hundred meters for heavy stones, with rate of fire of a few shots a minute once a crew found a rhythm. A sling on the end of the arm gave extra speed to the projectile and often outperformed the older fixed cup, which is why later designs favored the sling for longer reach. The frame sat on skids, so teams could drag it a short distance and correct the line of fire, though no one pretended it was nimble. It was a siege partner that liked solid platforms, level ramps, and a clear field of fire. Artillery officers watched humidity like hawks because the torsion bundles hated wet weather. They also kept spare washers, pins, and raw materials to retune the springs and keep the throw consistent. The machine taught both sides new habits. Defenders learned to duck and cover when pale stones rose into view and to rebuild crenellations thicker. Attackers brought screens and earthworks forward, used onagers to shield sappers and tower crews, and coordinated fire to pin heads down while rams worked the gate. A few late sources hint at cart or platform mounts for more mobile use, but the heavy kick and the need to recalibrate after each shot kept it closer to a planted gun than a roaming one. It is also worth clearing a common mix-up. The medieval mangonel that many people imagine was a traction trebuchet pulled by teams of men and not a torsion weapon. Rome's onager belonged to the torsion family, which came out of the Hellenistic engineering tradition and lasted in Latin manuals into late antiquity. Put all of this together, and the clever part is obvious. The onager turned animal sinew, wood, and iron into stored energy on command. It changed the shape of a siege day by day and forced enemies to fight under a rain of engineered gravity that did not care about courage. It also pushed commanders to think in zones and timing, not just charges and walls, which is the quiet mark of a weapon that moves warfare forward. Number 6. The Corvus. The Corvus was a boarding bridge that let Rome turn sea fights into something much closer to a land battle. Picture a heavy plank wide enough for 2 men to move across together and long enough to span the gap between ships. At the tip sat an iron spike shaped like a beak. Crews raised the bridge on a tall mast with pulleys, swung it toward the target, and dropped it so the spike bit into the enemy deck. Once the ships were pinned, Roman marines crossed in tight groups and did what legionaries trained to do on land. This simple shift mattered because early in the First Punic War, the Romans were not better sailors than Carthage. They were better at hand-to-hand fighting. The Corvus let them fight their war on water without pretending to be nimble oarsmen. Ancient descriptions and modern reconstructions point to a bridge about a meter and a bit wide and roughly 11 meters long. A knee-high rail helped men keep balance on a pitching deck. The support pole at the prow carried the load, and the pulley gear handled the weight. It was not elegant, but it was repeatable, which is what a fleet needs. In action, the pattern was straightforward. Roman captains closed distance without trying fancy rams or turns. They locked a target, slammed the Corvus down, and flooded the enemy deck with marines. That is how they won at early showdowns like Melee, and how they held their own at Ignomus, where hundreds of ships fought at once. The device changed morale as much as it changed tactics. Carthaginian crews, who expected rams and oar work, suddenly faced shield walls on their own decks. The fear of a short, brutal boarding rush made experienced helmsmen hesitate to come close. The Corvus came with trade-offs that every crew felt. It added heavy mass toward the bow and messed with handling. In rough water, the bridge could not be used, and the weight up front made ships wallow. Many historians think that is one reason Rome moved away from the device after gaining confidence at sea. Once Roman crews and officers learned the craft of maneuver and ramming, they no longer needed a crutch that slowed them down and raised risks in storms. Even so, the idea had already done its job. It let the Republic build a navy fast, win decisive battles early, and keep pressure on Carthage while their ship skills caught up. You can see the quiet genius here. The Corvus did not try to fix every weakness. It took one Roman strength and forced the enemy to deal with it at sea, on Rome's terms. Number 7. The Testudo formation. The Testudo was a moving shelter that let Roman infantry cross open ground under a storm of missiles. Picture ranks closing up until shields touched, the front rank holding scuta forward edge to edge, the men behind lifting theirs flat overhead so they formed a roof. Side files turned their shields out to cover the flanks. From a distance it looked like a low rumbling box crawling toward a wall. The idea was simple and ruthless. Keep arrows, javelins, and stones off skin long enough to reach the spot where hand-to-hand skill matters. It worked because every part of Roman kit and drill supported it. The curved scutum overlapped cleanly. The center grip let a man punch the rim forward or hold a shield steady above his head without twisting his wrist. Commands were short and drilled into muscle memory so dozens of men could change spacing on cue. The formation did not appear by magic. Recruits learned the exact distance to their neighbor's heel and the angle of a raised shield that closed gaps without crushing the man in front. Cornicens and centurions kept time with horn calls and shouts. Once the box was built, movement stayed deliberate. Crews pushing rams, ladders, or mantles often tucked into the Testudo's shadow, so one protected bubble carried several tools at once. In siege work, that mattered most. Defenders loved to rake approaches with arrows, sling bullets, and small stones, while sappers tried to reach the base of a wall or a gate. Under a Testudo, the column advanced through that kill zone with far fewer losses. The pressure on morale ran both ways. Defenders watched their best harassing fire lose bite, while a silent mass crept closer. Attackers felt the thud of impacts on wood instead of shoulders and ribs, which helped them keep pace and breathe through the strain. The formation had costs and limits that Roman officers understood. It moved slowly and hated uneven ground. A single stumble could open a seam where a rock or dart found flesh. Heat built under the roof and tested lungs on long pushes. The shield edges were not welded plates, so plunging shots from high towers, heavy stones, and pots of fire were always a threat. Commanders used screens, trenches, and counter-battery fire to blunt those dangers, then unleashed Testudo columns at the right moment, rather than from the first drumbeat. In open battle, it saw more careful use. The roof helped during arrow storms, or while closing against a missile-heavy enemy, but once within charging distance, the box loosened, so men could shove and stab in the regular line. That flexibility was the point. The same unit that looked like a tortoise one minute turned back into a wall of overlapping shields and short swords the next. What makes the Testudo clever is not just the geometry, it is the way it tied technology, training, and timing into one habit. Roman soldiers did not rely on courage alone to cross fire. They trusted a rehearsed shape that made incoming shots less deadly and gave engineers and assault teams time to work. In a world where most armies threw missiles and hoped, the Romans treated that phase as a solvable problem. The Testudo was their practical answer, and it changed how opponents thought about defending a wall, a gate, or a street under siege. Number 8. The Siege Tower. A Roman siege tower was a rolling staircase and firing platform that let infantry meet defenders at eye level on the wall. Engineers built a tall wooden frame with multiple floors and braced it with crossbeams so it would not rack under load. The outside was boarded and faced with rawhide and sometimes iron plates to resist fire. Crews soaked hides before an assault and hung wet screens along exposed sides. The tower moved on wheels or on logs used as rollers, with teams of men and draft animals hauling on ropes while others levered from behind. As it advanced, the lower decks carried sappers with rams and picks. The middle levels held archers and artillery crews who cleared battlements with arrows and bolts. The top platform carried the assault bridge, which dropped across the last gap so a shielded storming party could rush straight onto the parapet. Roman authors describe the logic behind this machine. You first neutralize the wall with missiles. You then make wall height irrelevant by placing your own ladders and bridge at the same elevation. Reliefs like Trajan's column show towers beside rams and artillery, which fits the combined arms pattern that Rome preferred. The tower was rarely a solo act. It worked with rams beating a gate, with trenches and manteles protecting the push, and with ballistae that blinded defenders who tried to burn the structure. Practical details mattered. The approach ground had to be graded flat. Fascines and earth-filled gabions paved soft spots so wheels did not sink. Carpenter teams pre-built sections and bolted them together near the front. Commanders timed the final roll with covering fire, so the last meters happened under a storm of outgoing missiles. We can see the footprint of this method at several sieges. At Jerusalem, the Romans built banks and raised works to reach the wallheads, which would have paired well with towers and bridges once the height was matched. At Masada, the encircling wall and massive ramp show the same principle of meeting the defender at level, and scholars note that towers or elevated platforms likely accompanied the final push. In Gaul, Caesar's lines at Alesia bristled with towers along the circumvallation to dominate the ditch and wall space in both directions. At Syracuse, we even hear of ship-mounted towers and boarding frames used to threaten high sea walls, which shows how flexible the basic idea could be. A tower forced defenders to fight on equal ground where Roman discipline excelled. It turned a vertical problem into a horizontal one and made a city think hard about every stretch of curtain wall, not just the gate. That is why it changed warfare. It made walls a phase to be managed, not a reason to quit.